What's going on, Rovers? It's Mr. Shalat back with another video. Today we're going to be talking about dial calipers. We just got done talking about a ruler, the metric scale, the US standard scale, how to read both of those. All right, today we're shifting into dial calipers. Now, a dial caliper is a precision measuring tool. It's like a hyped up ruler, okay? You're able to get very specific measurements off of this, whereas a ruler, there's a lot of guesswork, okay? And a typical ruler only goes down to a 16th of an inch. This is going to go way, way more precise and get down and be able to measure things really, really small, okay? Unlike you would be able to do on a ruler. So I'm going to share a PowerPoint out with you. I'm going to explain how a dial caliper works, all right? How do you read the measurements off the dial caliper? So let me share out my screen here. We'll take a look. All right, going to full screen. All right, let's talk about dial calipers. Let's go back a slide. I don't know why it's doing that to us. We'll read the first slide and then go into the slideshow because it was giving us a little bit of a pain there, right? So the dial caliper, okay, is arguably the most common and versatile of all precision measuring tools. It's used by engineers and manufacturers, all right, to be able to get very specific measurements. It's going to be able to take four types of measurements. This slideshow does a really, really great job explaining what those four measurements are. I will briefly list them now and we will go into each one in detail when we get to those slides. All right. So it takes four measurements. You can see a picture of a dial caliper. We do have a set here in the classroom. For those of you that are here in the classroom, you will get to use these if you're remote. Um, the measurements will already be provided to you. For today, we're not going to be taking any measurements with the dial caliper. Everything's going to be done on the computer. All right. So here is a dial caliper. I have sent you one digitally with a link so you can play around with it and see the numbers, how the whole tool works. We're going to explain what all the parts are called and how do you take measurements off a tool like this. You could take four types of measurements. Okay. You could take the outside diameter of an object. All right. You could take the inside diameter of an object, the step distance, and the hole depth. So there's four different ways to take measurements on here. You might be looking at it and say, well, I only see one. Okay. We're going to explain what each of those are. Okay. So there's four of them in total. I am not happy with how this is blocking that. I'm sure it's showing up that way on your screen too. Let me, we'll get out of the presentation mode here. All right. Let's maximize this and put me down here at the bottom. Okay, so we'll go with that. So as we mentioned, there's four different types of measurements. Okay, your outside diameter or thickness, your inside diameter or space width. And there's a slide for each one of these, so we're going to talk about them, all right, as we go through. All right, the dial caliper limit. The dial caliper that we'll be using here in this class is an analog 6-inch dial caliper, okay? This is 6 inches in length. It starts here 0, all right, and goes all the way down to 6. Total length is 6. Our ruler, okay, is 12 inches. A standard dial caliper is going to be 6. All right. So talking about each one of the different types of measurements you can take. All right. And again, this slideshow does a great job showing you the different types of measurements on the dial caliper here. Okay. So the first thing it says measuring outside length. Measurement made between caliper faces is shown. Example is the outside diameter or thickness of an object. So in between here and here, you're able to measure the outside of something. All right. When would you use that? Well, if we look at this particular object, all right, if we want to know from side to side, okay, how big something is, okay, in this case, the depth, okay, how deep is this particular object? All right, we would put it between those two caliper faces. That's going to give us our outside length dimension. All right. If we needed to measure something inside on the reverse side of the caliper, so here is our outside measurement. On the opposite side, okay, you have these two caliper faces, all right, and they're on opposite sides. They're not facing inward like here, they're facing outward, okay? This will measure like inside a hole or inside of a slot. Taking a look at the next picture here, okay? Here we have a hole and we want to know the diameter of that particular hole, okay? In order to do that, we can't use the outside diameter and put it on there and get a precision measurement, okay? We can't do that. So what we can do is we would stick the dial caliper in there and adjust these to open up to the maximum width of that space, okay? That would give us the inside diameter or the inside length. Two different measurements, okay? One thing to understand, that is the distance from here to here, okay, when this caliper is fully open, is the same measurement from here to here, okay? So however far this is open is the same measurement from here to here. At any time, you could take 4 measurements at the same time off of that dial caliper, okay? So 2 of them, right now the inside diameter is the same as these 2 faces here, which gives us an outside diameter if I was sticking that onto something, okay? Moving forward, okay, is the stepped distance, okay? The step distance. Now, on the reverse side of the dial caliper, okay, this was our inside. I'm sorry, this was our outside. This was our inside. And now on the right inside here, this particular line, on the reverse side of that, you have a flat line. This is known as the step distance, all right? And it will step down between 2 parallel surfaces. Taking a look at the picture here, okay? So putting that flat edge and drifting the caliper down till it touches this surface. As you can see, this is like a step, okay? So we have one flat surface here and one flat surface here. The distance between those two, all right, on the back of the caliper, you have that flat line and that drops down to the other flat surface here. That's known as your step distance, okay? That step distance, the distance from there to there, is the same as our outside diameter and our inside diameter. Those 3 measurements are exactly the same. So the distance from here to here and here to the other side of that and our step distance, all 3 of those are the same exact measurement, okay? All 3 coming off the same exact tool. Next, measuring depth, okay? So if you have a recessed hole, okay, something that goes into the shape and you can't get your dial caliper in there to measure, this is when you would use the depth feature. So as you're making your adjustments, okay, here's our outside, okay, here's our inside, and then we have our step distance. Those 3 are the same. Those 3 measurements, so from here to here, here to here, and from here to here are the same exact measurement. All 3 are the exact same. Well, coming off of the end of our caliper here, okay, right here, this is going to allow us to measure the depth. So you'll see here on the next slide, if you have a shape and they've cut away part of the shape just so you could see the inside, but just pretend that this was here, okay? What they're doing is putting the butt end of the caliper here and dropping down until it touches that surface. That's how you get a depth dimension. Okay, so 4 different dimensions that you can take with this same tool. Okay, four different dimensions. Let's talk about the parts of the dial caliper. Okay, the dial caliper, there's all different names, okay, for the parts that we're going to be referring to here. So this here is known as the blade. Okay, the blade is that long handle. The blade is what you're basically going to hold on to when you're working with the dial caliper. Okay. Over here, we have the slider. The slider is the thing that's going to move back and forth along the blade. Okay. So breaking it down, zooming in. Okay. On the blade, there's a series of numbers. Okay. The larger, bolder numbers, those are the inch marks. Okay. And each inch is broken down into tenths. So here is 0.1, 0.2, 0.3, 0.4, okay? And then you get to 1.1, 1.2, 1.3, all right? So when you are taking your measurements, you're always going to record two numbers off of the blade. Always two numbers. So when you're looking at the blade, before you even look at the other parts that we're going to get to in a few minutes, there is always two numbers coming off of here. So if I am recording, let's say where this arrow is at, I am recording 0.6. I wouldn't record just 0.6. I need to record the zero. So 0.6, okay, or 1.8 or 2.4. You're always going to record two numbers. Remember, the larger bold numbers, those are the inch marks, and it goes all the way up to 6 inches, okay, because we have a 6-inch dial caliper. So you're recording two numbers off of the blade. Remember, two numbers off of the blade. I know I'm repeating myself, but I'm doing that on purpose, okay? Always two numbers you're recording off of the blade. Moving through some other parts. Okay. You have your dial and you have your pointer. Okay. Your dial, okay, has a series of numbers that go all the way around from 0 to 99. That's the dial. The pointer, okay, is the little needle that's going to point exactly where you are at on the dial. Okay, so the dial has 0 to 99 numbers, and then the pointer is the needle telling you which of those numbers it's pointing at on the dial. Okay, now for every rotation that this goes around, okay, so it goes 0, 10, 20, 30. When it gets back to 0 again, it's now gone 1/10 of an inch. Okay. So the pointer rotates along with the dial as the slider moves back and forth. Remember, this whole carriage here, this is known as the slider, right? It moves back and forth across the blade. The blade is the long handle, right? Reference edge. The reference edge. So at the end of the slider, you have a metal edge, and that edge represents the reading that you're taking off of the blade. Okay, so here it says the reference edge keeps track of the larger increments. Example, 0.1, as the slider moves along the rack. Okay, so what you have inside of the blade is a series of teeth. Okay, think of gears. All right, those teeth allow the slider to move back and forth. All right, every time that this goes around one full rotation, it is revealing one more tenth of an inch along the blade. Okay. We read that off of the reference edge. So where do we look? What number do we record? It's wherever this line here ends up. Moving forward. The rack. Here they show a better picture of it. Okay. It's the rear tooth gear used to change the linear motion of the slider to a rotary motion to the pointer. All right, so what this is doing is coming across. There are little teeth in here, okay? And as you move The thumb wheel, okay, the thumb wheel is much like a lighter, which is going to allow you to move um, the slider back and forth along the rack, okay? These teeth are coordinating with over here the pointer, okay? The pointer is that little needle that's pointing out which number on the dial you're about to read. Dial caliper interpretation. Accurate dial caliper requires several steps, okay? Number one, they want you to zero out your dial caliper, okay? When this thing is fully closed, okay, when these teeth are fully closed, it should be reading right at the zero, okay? It should be reading right at the zero. If it is not reading directly at the zero, you have to make an adjustment, all right? And to do that, what you end up doing is adjusting this knob here. You twist the dial until the pointer is directly at zero. So you have to make that change. All right. You have to zero it out because the measurements that you're taking are totally pointless if the thing is not zeroed out. If you're starting further, okay, if this number is not at zero when you're starting, your measurement's wrong. Okay. So we have to always make sure that this is set at zero. If you use a dial caliper in class, I will walk you through and actually show you how to do it one-on-one. Okay, it's much easier for me to show you than discuss it over a video. All right. All right. Oh, jumping all around here. All right. So dial caliper interpretation. This is something we've already talked about. Okay. Each time the pointer completes one rotation with the dial, the reference edge on the slider moves a distance of 0.1. So every time this goes 0.99 back to zero, one more of these numbers will show. Okay. So the number, the line actually shows up after the number. So 0.1 isn't until it gets past that line. That line there is the equivalent of zero. If we're looking on here, this is 0.7. How do I know it's 7? Because it's reached the zero, okay? If it wasn't on zero, let's say it was over here somewhere in the 90s, it would be 0.6. It would not be 0.7, but once it gets back to the zero, then you go to that next number, okay? Moving forward, one revolution with the pointer within the dial represents 1/10 of an inch. We've repeated that about 3 times now. The dial is divided 100 times. Therefore, each graduation equals 1/1000th of an inch. Okay, what does that mean? Well, I told you earlier that you're recording 2 numbers off of the blade. Always 2 numbers, okay? So like 1.8, 3.2, there's always 2 numbers. Then you're going to record 2 numbers off of the dial, okay? Those numbers can be 0 to 99, okay? Somewhere this is going to land. So you have to look and see where it is landing. Let's go to the next slide. To determine the outside diameter of the pipe, first identify how many inches are being shown on the blade. Okay, we'll do that. Well, when we look at this, the first thing we have to do is we have to record 2 numbers that are off of the blade. These are significant digits. They are non-arguable, okay? These are numbers that are exact, okay? These are numbers that there's no variance whatsoever in the numbers that you're recording. So the first 2 numbers that I'm going to record here, all right, when I'm looking at this are 1.4, okay? I know it is 0.4 because it is past the line, okay? If it was before the line, it would be 1.3. So the first 2 numbers I'm going to record for my measurement are 1.4, okay? The next 2 numbers that we record, all right, we look at this dial. Well, on the dial, and I wish I could zoom in a little bit more for you, but I can't right now. All right. In between 30 and 40, there are 10 lines. Well, actually 9 lines. The 10th line would be 40. So as we come across, and you think in terms of, okay, you have 31, 32, 33, 34, you go all the way across, and then 39 and 40. All right. What they're saying is this needle right here is landing on the 7th line there. So it would be 37. Remember, you're recording 2 numbers off of the blade. Those numbers were 1.4. And now you're recording 2 numbers off of the dial. Always 2 numbers. 2 numbers. So when I look at this, the next 2 numbers are 37. So far, my measurement is 1.437. 1.437. Those are the numbers that I've recorded so far. All right. Then we go to this slide. Okay. And now we have our close-up that I wanted to show you. Okay. Our last number that we will record, the 5th number, will be your best guess. Okay. Much like when we talked about the ruler, okay, whether it was US standard scale or metrics, it will never land directly on one of the lines. Okay. Odds of it landing on the line are, 1 in 10 chance. So we look what's happening right now. We can count over, okay, 1, 2, 3, 4, 5. Notice the line's longer. So 35, okay, 36. Here's 37. All right. But it didn't land directly on 37. It's actually a little bit past. What you have to imagine, okay, this is where you're going to give your best guess. And when I say best guess, in between 2 of those lines, so between 37 and 38, you have to imagine that there are 9 lines there. Now, if it's landing closer to 37, it'd be a 1, 2, or 3. If it's in the middle between 37 and 38, it'd be a 4, 5, or 6. And if you feel it's really close to 38, but it's not there yet, that would be a 7, 8, or 9. So you have to use your best guess. Now, what they're telling us here on this slideshow right now, they're saying that this is 1. Okay. So when I say 1, that's 1/10,000th of an inch. Okay. 1. Well, for that number there, I would also accept a 2. Okay. So anyone that gave me the answer of 1.4371 or gave me the answer of 1.4372, they're both correct. Okay. They're both correct. There's going to be that little bit of wiggle room. Okay. So plus or minus 1, I would say it doesn't necessarily land directly on the line here. All right. It's a little bit past. So if you put a 1 or you put a 2, both of those are going to be acceptable answers. All right. Both will be acceptable. But you're always recording 5 numbers. That is not a debate. 2 numbers come off of the blade. 2 numbers come off of the dial. The 5th number is your guess, 1 to 9. Where do you feel it landing? Okay. If you feel that it's right on the 0, that number would be 0. Okay. So if this pointer coming in here was right on the line, that 1 would be a 0. And the final answer would be 1.4370. Okay. Don't just leave it blank. You have to write 5 numbers down. All right, moving forward. Here they're showing the addition. You just add all those numbers up. All right. Here's a practice problem. Okay. How wide is this block? All right. Well, when we look at it, unfortunately, the answer is already on the screen here. All right. But when we look at it, how wide is the block? We look at our numbers. Okay. I record 2 numbers off of the blade. I'm not even looking at the dial yet. I could care less what that says. I'm looking here first, and I'm recording 2 numbers. All right. I know it's 1 something because the 1 has been revealed and we come across and it's 1.4. But is it 1.4? Did it get to 4? Or is it at 1.3? Well, that's when I come over to here and I could see it's past the 0. Therefore, I'm going with the 1.4. First 2 numbers are 1.4. Next 2 numbers I'm going to record come off of the dial. Okay. When I look at that, Here, it's coming over to the second line, okay? So the next two numbers I record are 0, 2. 0, 2. Not 2, 0, 2. Two numbers. This is why it's important you record two numbers, because 2 would be 20. 0, 2 is 2. Does that make sense? If we are at 1.4 and I write 2, 2 would be 20. That is not right. It's 0, 2. Okay? Because anything that lands between 0 and 10, you got to bring the 0. Okay? So it's 0, 2, and then we look at where it's landing. Okay? Where in between 2 and 3 is this landing? You have to imagine that there's 9 lines in there. Okay? To me, this is close to the 2. So I would record a 1, 2, or 3. I would accept all 3 of those answers for this particular one. There is a little bit of variance, okay? So one of those 3 numbers. The last one is your best guess, best estimate. The first 4 are non-negotiable, okay? Those are significant digits. Those are already accounted for, all right? But the last one, you're going to use your best guess of where you feel it's landing, all right? So what are we doing for today's activity? Well, normally what I would do is I would pass out the dial calipers and I'd let you start measuring. Unfortunately, for the people at home, I've got remote kids, I got kids in class, I got kids, hybrid at home. So what we're going to do is I have set up a homework activity, but it's set up as a quiz. Okay. There is 9 examples. Basically what we just did here with the block, you're going to do 9 different problems with those. All right. So when you go to take the quiz, you'll see a picture of a dial caliper, okay? And it's asking, what is the measurement on this particular dial caliper? And you're going to have to enter those numbers. Please, when you go through the assignment, make sure you're recording 5 numbers. Don't record 4 numbers. Don't record 3 numbers. You have to have 5 numbers in order to get credit for the assignment, okay? I have put into effect, okay? So if the answer was 1.4022, I have put in 2.1 and 2.3 as acceptable answers. So you could not necessarily have the same answer as the person sitting next to you and still be correct. I have the variable answers in there as well. All right. So using what you learned off of this activity, okay, I would like you to try the online link that I gave you. It's a dial caliper. You're able to move the slider around and actually see how a dial caliper works. All right. But then go into the activity, give it a shot, 10 questions, and then you're good. All right. That's how you read a dial caliper. Please make sure you are recording 5 digits. Okay. You have to be recording 5 digits when you're doing this particular activity. All right. If you have questions, please hit me up and have a great day. Talk to you soon, Rivers.